Every triangle hides a secret that feels impossible. Draw any triangle and extend one of its sides. Instantly, a new angle appears outside the triangle. At first glance, it seems completely unrelated to the shape you just drew. Yet, no matter what triangle you choose, this exterior angle always equals the sum of the two interior angles on the opposite side. One angle sitting outside somehow knows exactly what is happening. At two corners, it doesn't even touch. How can that be? Stickman didn't believe it. Surely it was just a coincidence. So he tested it again and again. He drew tiny triangles, enormous triangles, narrow triangles, wide triangles, and triangles pointing in every direction. Each time he extended a side, the same astonishing result appeared. The exterior angle always matched the sum of the two remote interior angles. Different shapes, different sizes, the same mysterious relationship. After enough experiments, coincidence was no longer an explanation. There had to be a hidden rule connecting these angles. Searching for an answer, Stickman remembered one of the most reliable facts in geometry. The three interior angles of every triangle always add up to 180 degrees. Then he noticed something else that seemed unrelated. The exterior angle and the interior angle beside it formed a straight line, and every straight line also measures exactly 180 degrees. Suddenly, two completely different facts were producing the very same total. That couldn't be an accident. If both expressions equal 180 degrees, then they must be equal to each other. Remove the interior angle they share, and the mystery disappears. The exterior angle isn't behaving magically at all. It is simply equal to the sum of the other two interior angles. The secret was never hidden inside the exterior angle. It was hidden in the relationships between all the angles. Now the theorem becomes a powerful tool. Imagine the two remote interior angles measure 45 degrees and 70 degrees. Without measuring anything, you already know the exterior angle must be 115 degrees. No protractor, no calculations beyond simple addition. The answer comes directly from understanding the structure of the triangle rather than measuring every angle individually. This is one of the greatest strengths of mathematics. Instead of relying on observation alone, it allows us to predict the unknown using logical relationships that are always true. That is why this simple theorem appears far beyond the classroom. Architects use geometric relationships to design stable structures. Engineers rely on them when analyzing forces and mechanical systems. Computer graphics use them to render realistic shapes and animations. Robots use geometry to understand movement and orientation. Again and again, mathematics replaces measuring with reasoning, making complex problems far easier to solve. What first looked like an impossible coincidence turns out to be the inevitable consequence of two beautifully simple facts working together. The triangle never changed. The angles never changed. Only our perspective changed. And perhaps that is the deepest lesson mathematics has to offer. It is not a collection of formulas waiting to be memorized, but a language of hidden connections waiting to be discovered. Every theorem reveals a pattern that was always there, quietly holding everything together. Once you begin to see those patterns, every diagram becomes a puzzle, every puzzle becomes an opportunity for discovery, and every discovery reminds you that mathematics is not merely about finding answers, it is about learning to see the invisible logic that has been there all along. If one ordinary triangle can hide a secret this elegant, imagine how many more mathematical mysteries are still waiting to be uncovered.